Gunderson. Ethan Gunderson on everything that's important on the internet. From Chicago, not from Canada. I apparently have an accent that confuses people. I've never been there, so I'm a tech lead at Groupon. I've been there for roughly about 15 months, which has given me the benefit of seeing a relatively average size Rails code base grow to be ginormous. So we've learned a couple of things along the way, specifically about ActiveRecord and scaling it. The first part is ActiveRecord is a great tool to get you 80% of the way there. So you can get up and running in your application really, really quickly. This starts to totally break down once you have real users. So as soon as you start to scale, you immediately start feeling the pain of some things in ActiveRecord. This is actually semi-real code that I found in our code base, and my face just melted when I saw it. It's hopefully everyone knows why that's pretty terrible. I'll go over it just to make sure everyone knows. But so this was the impetus for this talk, was seeing stuff like this. So this is a talk that's basically common mistakes that we make when dealing with ActiveRecord. This could also be called ActiveRecord Safari. So some of it's going to be review. If you run a large Rails site, you probably already heard some of this. Hopefully I can teach you some new stuff anyways. So let's start with that first mess of code that I showed you. So ActiveRecord, well, every abstraction by definition is leaky, right? At some point you'll get to dealing with your code where you'll need to understand the layer below that you're working, what's being abstracted away. With ActiveRecord, unfortunately, that happens instantly. But you don't actually realize that you need to know what's being abstracted. So it becomes really dangerous. If we look at this code, it's all Ruby, but it's doing very, very different things, right? So Order.all is executing a database query. It's pulling every order in that table into memory, constructing ActiveRecord objects, and then we're throwing a bunch of them out in Ruby, just for fun. And then we're selecting the ones that are open after that, which is buggy in itself because you don't actually guarantee that you're having an open order at that point. And the sad part about all of this is, and this is super easy to do correctly, creating a simple scope on your order model and using the limit call that's given to you. This puts all of the work on the database, and databases happen to be pretty good at dealing with data, which is crazy, but so I take it almost everyone knows to do stuff like this over stuff like this, right? So another pain point that we had to deal with was running typical ActiveRecord migrations. So we use MySQL, and the pain that we're feeling mostly has to do with how MySQL handles alter table statements. So in our example here, we're writing an email and a status onto our users table. Our users table could be anywhere from 5 to 80 million rows. Depends on where you're at your scale, but this is how MySQL handles that actual migration. So we're going to lock the table, so no more writing. We're going to make a whole copy of that table. Then we're going to make our change that we want, and then we're going to promote that copy into the primary. And now since we have two statements, we're going to do that twice. So if it takes an hour to move all your data around, you're going to be doing that twice, so 2 hours, or 3 hours, depending on what you're doing. This is bad, especially if this is, so it's our users table, so no more users for the next 2 hours can sign up. It would really be bad if that was your purchase table. I don't know if I could tell my boss that we won't be selling anything for the next 3 hours. But. So there are 2 different ways around this problem. One is kind of nasty, and that's just to write raw SQL. So we're just executing SQL directly, altering the table. if you're lucky enough to be working on a...
So is that actually guaranteed to be transactional then, in between two columns?
I don't know.
Because I don't think you can count on that being transactional either.
Does anyone know? If this is transactional between...
Adding the first column and the second column.
I believe it is.
This one would be an atomic chain.
Yeah, okay, so this is right. For MySQL, this is, all right. If you're using, I think Rails 3 when this was introduced, you can throw the bulk flag on, which would do the same thing as what we did before. I have no idea why this isn't the default, except for that it's only in the MySQL driver, so it's not for Postgres. But very cool, definitely use it. Then just important to keep in mind these different leaks in the abstraction. It's definitely a benefit to be aware of them. So the next thing I want to talk about is not optimizing your queries. So we're back to our familiar statement of grabbing every order in the system, which is kind of not a real great example, because you would probably never want to do this, unless if you're running some global every sale ever report. Normally you'd limit it down somehow, but regardless, if this is a really big collection you're iterating over, that's going to be really painful. So what actually ends up happening is, when we do this, we're going to iterate over the database cursor, and then we're going to build up an array of rows, and then we're going to initiate ActiveRecord objects for each row that we get back. Depending on the size that you're working with, you can be consuming huge amounts of memory. So we have two different ways to work around this, which I think are pretty cool. The first one is find each. So what find each does for you is it iterates over the collection in batches. So by default, it'll grab 1,000 records from the database, and it hides the iteration from you, so you still just get an order, but you're only pinging the database for 1,000 at a time. And then you can override that to be whatever you need it to be, I guess. And there's also find in batches, which allows you to do the same exact thing, only except it exposes the iterator to you. So if you need to do further limiting on it, or whatever, you have the array of ActiveRecord objects. So that's super low-hanging fruit in most projects. That simply remembering to use find each or find in batches can save you a lot of memory space. N+1 queries. So we're using our same example. We're iterating over all of our orders, and then for every order, we're going into the user's association and grabbing first name. So this means that we're going to be having an extra database call for every time we hit user. This is normally pretty bad, and it can cascade really fast. So this actually comes from another example that I found, which was one of our reports would do something similar to this, only except it grabbed probably 15 or 16 objects in the graph. And for larger reports, it ended up issuing about 8 million queries. It didn't work. Like, surprise. All right, so we can fix this pretty easily by just including the user stable. So we'll do a join on this and grab all the data right away. And we can cascade this down too to grab as many associations as we need. You still have to be careful with this. We're still bringing a bunch of data into memory. So combining this with finding batches or find each would be the way to go. One tool that we use quite a bit, which helps us find crap queries like this, is Query Reviewer. So what this does is it places a little clickable tag in the upper left of your window, and you can click on that, and it'll show you all the warnings and critical queries that it finds that rendered on the page. Pretty decent. Another thing that I recommend is always having ActiveRecord log out to a console. It's really easy to see a flurry of queries fly by. You know something's wrong with them. So I'm going to talk briefly about some race conditions that you can have pretty easily in ActiveRecord. And the one specifically I want to talk about is validates uniqueness of. So validates uniqueness of is interesting in that it doesn't actually work all that well. So this will work up until about the point you hit production. This is assuming your production system has 2 mongrels, not just one. If you're running on 1 mongrel, then you'll be fine. But so let's see how this happens. It's pretty simple. So we have 2 users. User 1 wants to create a record. We check for uniqueness. The database returns true. User 2 comes along and wants to do the same exact thing. Well, no insert has happened yet, so it's going to return true as well. And then both of them have the OK to insert. And success! No, danger! We have integrity issues now. And this doesn't have to be 2 separate users either. This can be 1 user that's really impatient and double-clicking. And if you don't have JavaScript protection on double-clicking buttons, this can happen there too. I don't know what's causing that static. Sorry, guys. So the easiest way to fix this is by specifying a unique index. This will prevent this from happening. This kind of goes against the Rails train of thought of business logic belongs in your application. I think that's kind of crap, and that this is an integrity issue. So I want my database to maintain integrity. Kind of up to you, I guess. The only other way I know to fix this is to change the isolation level whenever you're actually doing an insert, which may work if only one application is talking to your database. In our case, our database is shared across a couple different applications. So we can have 1 unique index here every place where we have to access it. Remember to have changes in our isolation level, which, fair choice, I guess. There's a gem to help you find these called Consistency Fail by Colin Jones. It's a really quick executable that you just run against your project, and it'll find validates uniqueness of that isn't backed by unique index. It'll find has 1 relationships as well. So another part that we've had a lot of pain with is callbacks, that we abuse the hell of callbacks. So the first pain point that we really started to feel at scale was loading additional associations inside of callbacks. So in this example, we want to validate the credit card on the order is associated with the credit card of the user, which is kind of, maybe not the best example, but it illustrates the point that we have another query to load up the user object now. And so that cascades, right? So if this one callback has 1 thing that it's loading, and you have 10 callbacks that are all loading 1 piece, you have 10 additional queries that are going to happen. Probably one of the best ways to take care of this is watching dirty attributes. So only actually do anything if the credit card had changed. So if the credit card ID never changed, you don't need to do anything, right? So you can just totally skip it. Pretty simple. It gets slightly worse in cases like this, where we're calling methods on other associations now. This is bad for a couple of different reasons, in that it's slow, that it's extremely hard to debug when something goes wrong in production. So let's see how something go wrong. So in our case, we have an order that has a callback that touches an item. So we're updating something on the item. So now our item's going to go over in a callback and change something on the vendor, which maybe goes down to some sales thing, or the object graph can get pretty deep if you're dealing with callbacks like this. Then inevitably, somewhere, someone's going to return false from a callback. That's going to halt the chain, and nothing will save. So all the way back up in your totally unrelated order item, you can't save. We've seen this happen for cases where like our vendor was not in a valid state. So because of something way over here, we can't save this object over here. That's really hard to figure out in production. So keep callbacks simple is the model there. The next thing I want to talk about is breaking the law. And that's all. Law of Demeter. So law of Demeter is a really relatively simple kind of concept. Each unit should only, don't talk to strangers, basically, is the thing. So this is like a typical explanation. I like this one a lot better. So you play with yourself, play with your own toys, play with toys that were given to you, and toys you made yourself. Anything more than that, and don't do it. So like this would be a Demeter violation. So we're going from our order object, we're reaching through user and grabbing our address association. So this is bad. But why do you care? That's super easy to do. You see it all over in Rails applications. You should care about it because of coupling. So, and through this graph that I made up, we can see that the higher your objects are coupled together, the higher the cost of change. So we don't want that, right? We want things to be easy to change, so we want them to be less coupled. And we have proof. So we get a pretty easy way to kind of deal with this, in that we can delegate things to other associations. So in this case, we're delegating the address to our user class, and we're calling a prefix and allow nil, which gives us this type of method. So now we can call order user address and make it back that address object. This kind of solves the issue in that it makes it easier to change. So if we needed to change the implementation, we could just override the user address on the order object, if we needed to make the change. I'm not totally sure how I feel about this. It still feels equally as dirty. Other people use presenters to try to get around this. Yeah. If anyone has thoughts on that. All right. So just a quick recap. So pay attention to the abstraction. It leaks like crazy. Just know about it. Optimize those queries. Avoid complicated callbacks. It's the law, follow it. And finally, the database is your friend. We tend to get in this habit of abstracting it away and pretending it doesn't exist, which is, in my opinion, pretty bad. Our database holds our data. Without our data, our application is rather useless in most cases. So we should care about our database. And like everything, your mileage will vary on all of this. Like I said, we ran into these issues at scale. For a smaller site that you're trying to grow, it may be easier to make some of these mistakes in churn for faster velocity, getting features out the door. Just be aware that it's technical debt, right? So at some point, you're going to have to pay for it. Thanks. I have time for questions. All right.
Why did you feel a little bad about using delegate to get around?
Yep. So why did I feel dirty about using delegate to get around a Demeter violation? It didn't feel that much better in terms of coupling. Like I'm still, I don't know, to be honest.
I was thinking about, and in a way, it makes it less, it abstracts away that you're hitting another table. And so as you talk about it, with some of your other things, it actually makes it, you may not realize that this is actually causing another query in another table. So,
that's true.
And if you don't do an include, in certain cases, that.
And with that example specifically, now our order class has methods about users on it, which feels kind of like a violation of single responsibility, especially in the part where we changed it. Like, I almost feel that's where a presenter might come in better, but I can't say for sure. Any other questions? Comments? Complaints?
Are there any other tools that you would recommend to help find some of these things? You mentioned a couple of gems. Is there anything else that, as you're working there on your app, that you use that helps you with these scaling issues?
Running explains queries. So when you see them come across an active record, run them through a MySQL explain. The thing to be careful there with MySQL at least, it's completely stats-based query planning. So if you don't have like a relatively accurate table size, you'll get different query plans locally than you would in production, which has been us before. So if you do a U18 environment that you can run an explain against that has production-like data, that's helped us a bunch.
Are there things that you guys run outside of ActiveRecord? And what types of cases would those be?
The things we run outside of ActiveRecord.
I mean, do you run all of your queries through ActiveRecord?
Yes and no. Everything inside of our Rails app is ActiveRecord. We use Vertica for large recording, but that's outside of the actual main app. But we actually write a bunch of raw SQL too. Cool. Thanks, everyone.